Around 10-15 minutes after you can tell. But you can post it there and then you can read the name also. Understood, no?
Good evening all. Just audio check. Good evening. Yeah. Welcome to the series and orientation of demo on IEEE transactions. So we are on a day 6. So Pantech e-learning in association with an IETE, Indian Institute of the Institute of Electronics and Telecommunication Engineering. Okay, myself Hemastri, a project engineer on embedded systems. Currently I am dealing with projects research on deep learning and ML in a real-time implementations in a Raspberry Pi and Jetson Nano. Now, very good evening to all. I hope you all are having a great day today. Yeah, good evening to everyone. Wait a second. Welcome to the series and orientation of demo on IEEE transactions. So we are at day 6. So Pantech e-learning in association. Okay, so today's our topic is the real-time implementation of driver drowsiness and yawn detection. So we know that, so we are listening in our day-to-day life in our news channels, every person like those who are feeling sleepy in the nights, like some accidents will happen. So to avoid these kind of problems, we have come up with this solution. So the driver drowsiness detection. So we have an IEEE analysis. So as per the college outcomes, we have come up with a main with an IEEE reference papers, and which has the college outcome based, academic outcome based, like the main objective of the project and existing system and literature reviews, proposed system. These are the top, block diagram, module explanation, UML and algorithms we are going to use in this project. And finally I'll show a project demo how to implement this in a real time. Okay, so these are the things we are going to cover today. So before covering to this, so first we will discuss the problem statement. Okay, we are seeing so many of the areas the person feels sleepy and he can't able to control his. So we need to alert him, right? So for that purpose, we are going to give some alert systems. So previously we have any systems. So I take one reference paper I studied. So this is thing, camera based eye blink detection algorithm for assigning driver drowsiness. So basically based on eye blinkings, so we have any feature called we can if you are feeling sleepy, the eyes will close automatically, right? So in the same way, so here that this paper represents the eye blink detection algorithm for assigning the level of drowsiness detection using driver. So like generally also, so what I felt is generally we are feeling drowsy, right? So I thought like what is the sleep attention, like somebody or feels sleepy, what are the features of your face? First he will yawn and then automatically the eyes will also close. So then we are decided to do the extension of this project, the drowsiness with an yawn. So both we need to attention. We are going to concentrate on yawn as well as drowsiness. So when the two things will happen, so then the person is exactly feeling drowsy. But in this paper they discussed about the eye blink detection, so which will help you to identify the drowsiness. So they will study the paper also here, so which the intensity ranges, like the person who feel really sleepy, the intensity range of eye blinking and normal person blinking range. So by using some threshold values they are going to calculate here. Okay, so then I felt that if you are having a yawn detection also, then it should be very effective to identify. And then we are going to add a feature called SMS alerts to our friends or our relatives or anyone. So those who are very familiar with us, it is very useful. If you are supposed to going to meet an accident, they'll alert you very easily. Okay, so the main objective of this project are the real-time implementation, drowsiness and yawn detection. An existing system we are seeing like by using IR sensor in a hardware. I am telling about a hardware. So in a project features also, like I take a reference paper, in that they did in a software, like in a Windows they are implementing this, but it is too hard to implement in a software in a real time. So then I realized I need to implement these projects in a real time, like a Raspberry Pi or even Jetson Nano. So both are working on a Python. So I chose the first preference is a Raspberry Pi device. So if you are seeing previously the drowsiness detection using some hardwares like yawn detection. So the IR sensor placing on eye for fainting detection. The problem which is with this IR sensor is, if you keep the IR sensor near to the eye, it may affect to the eye. So, and buzzer and some jumper wire systems, it should be somewhat difficult to handle the entire system. So even we are designing some spectacles like to wear that the entire drowsiness detection using an IR sensor. For suppose I am wearing that, it is suitable for me. It is the spectacle sizes are different from person to person. So to avoid these kind of things, we are implementing the drowsiness in a real time with a complete attention with an feature extraction of the sleeping features of the particular person. And here is the literature review. So what I tell is in 2017 somebody did the eye detection with using eye localization system in an embedded system. Only the eye localizations are differed, and then we are referring the by using SVM algorithm they did it, and then the drowsiness region landmark identification. So using based on eyeball movements they are able to detecting. And then visualization, so based on the information, the eye blinking information, another paper we are taken. So these are the references I got from the IEEE transactions in 2017, 16 and 2018. And in a proposed system, I added the feature of yawn detection as well as SMS feature, which is going to connect with an IoT. The real time, the image processing is going to be connect with an IoT by adding SMS. Even SMS also, we are depending upon the GSM systems, but here we are introducing a cloud system which will help you to send an SMS through the cloud. By using an internet, we can able to send an SMS with a free of less cost. And then after we are going to add from buzzer alert to the driver. First initial alert is about to buzzer alert and then SMS alert. The two alerts we are adding, the SMS will send it to the person which we are given a number, Twilio number, by using the Twilio cloud is which is similar to the way to SMS or WhatsApp messages or anything. Even if you want to connect even WhatsApp also, but the Twilio cloud is about to somewhat good security standards I felt. So that's why I implemented the Twilio cloud in this project. And then so we see what are the hardwares required. So we required a buzzer and then web camera and then Raspberry Pi, finally SMS alert. So based on these two, these are the things we are going to use. I just show you the Raspberry Pi what I have now. Wait, I enable the camera. So this is the Raspberry Pi I have, and then buzzer. Okay, I have the camera also, but I connected to the system, so later I will show it to you. Okay, so these are, and then I take for power supply purpose, I take one USB cable. Okay, so these are the hardwares required to implementing this. And this is a workflow of this. So if you want to going to working with entering into the project, first we need to start the enable the live streaming, and then after we need to detect the face and then eye and then mouth. So we need to extract the features of the face, eye, mouth, likewise. And then we need to count the ER values. So ER aspect ratio, so ER like whether eye is blinking or not. So based on ER values we are going to discuss. I will discuss in coming slides. And then detecting the person is drowsy or not, and then alarm system. So this is the workflow of this entire project. First we need to know how to enable the camera and face detection. So after face detection, facial extraction like eye detection, and then mouth we need to detect, and then counting the ratios with respect to the blinking. What's the ratio when I close the eye, what's the ratio, and when I open the eye we need to cleanly watching and cleanly monitoring these parameters. And then detecting the drowsiness. So now based on a threshold limit, so we need to detect the person is drowsy or not, and as well as mouth also. So we are calculating the mean distances between the eye thresholding values. Okay, so one by one I just going to give the modules. I divided this project into the mainly 5 modules. First one is about to Raspberry Pi, and then buzzer, detection of face by using hair cascade, and then D library, which will help you to extract the features of the person or any like eye, mouth, likewise. And then SMS alert using Twilio cloud, and then real time implementation. Okay, the first discussion is about to the Raspberry Pi device. We know that Raspberry Pi is very minute. Okay, So this is a Raspberry Pi, which is a miniature circuit. It is like a CPU. Okay, credit card size CPU. You can able to see here. I am just enabled my camera, which is visible on the screen. So this is a Raspberry Pi. You can connect by using this HDMI cable. So this is the HDMI cable. We are going to connect any PC or anything. If you have to see any monitor, first we need to write code and entire things, right? So for monitor purpose we can use, and these are the HDMI cables which will help you to connect the camera. And I just keep the OS here, the Raspberry Pi OS. So we have to install certain modules. What are the required modules, I'll tell you. So we need to install all the modules and everything, which should be a pre-installation OS. I just take it, and so I just gave you a brief description about this. All these are the 40 GPIO pins, general purpose input output pins. Like this is like a CPU, which is very similar to the CPU. So but I need to make it more like by adding the hardware. So if I want to connect this buzzer, all these kind of things, I am using these GPIO pins, general purpose input output pins. And then I am going to just use this by using these USB ports. I am going to connect the web camera, and then internet purpose. As usual, we have an inbuilt Wi-Fi module here, but anyway, if you want to use any LAN connections, we can use it here. And this is for text to speech conversions or anything, and this is about to power supply. Okay, so this is about the Raspberry Pi device. So I just explained in a same thing. The dimensional total 4 ports are available, everything CSI. This is about to Pi camera. So total for this Raspberry Pi we can able to connect the camera in 3 ways. One way is by using IP camera, which is already demonstrated in so many of webinars. If you want to know how to connect the Raspberry Pi with web camera, just go and watch the previous videos, and we are giving the entire architecture very cleanly in a previous webinars. Just go through that if you want in-depth information about Raspberry Pi device. And first we need to set up a camera that monitor the streaming or face. In a face, this is the step-by-step process. So we'll apply facial landmark detection and extract the eye region as well as mouth region. So how it is going to be extracted? So because by using a hair cascade classifier. By using hair cascade frontal face default XML classifier and DLIB. So DLIB is particularly for which will help you to extract the features of the information. So because this can be happened by using 68 facial landmarks on a face. So this is how first the camera is activated, and to detect the face, these 68 facial landmarks will help you a lot. So here for suppose the eye landmarks are there. So in the coding, if I want to extract the eye features, I need to mention it as a with an XY coordinates of the frame with these values. So the feature consisting of in between 37 to 40, the landmarks localization for left eye, this is about to 40, 37 to 40, sorry 42, 37 to 42, in the right eye 43 to 48. In the same way mouth also, so total 68, from 50 to 68 facial landmarks the mouth will be recognized. From 50 to 68 is all about to mouth. So to try this entire thing we are using an DLIB facial landmark detector. As if you want to detect the face detector, first we need to train the entire face, the 64 facial landmarks by using hair cascade files. So then after we are going to detect this purpose, we are using DLIB, and is about to come into the college outcomes. If you want to build any project or anything, first we need to focus on a UML. First the UML in the sense unified modeling language in a way to visualize our design of a system. Okay, so if you want to draw any system or anything, so generally if you want to build any what we call it as any buildings or anything, first we require a blueprint, right? In the same way for our project also, first we need to get it our outcomes. So to build an UML we require mainly three things. One is a use case diagram, we call it as, and then class diagram, and then activity diagram. So the use case is defined about the list of actions and even step interaction between the roles. Like for suppose we have a different, what are the things we are going to given, the inputs are based outputs. So then we are going to use about use case based on between the roles, it is playing it as an intermediate, which kind of modules are playing it as an intermediate in between two modules. So then we call it as a use case diagram, and then a class diagram. So this is the main blueprint or building blocks of the project. And then activity diagram is about to stepwise and workflow. So the one by end-to-end workflow will defined by using activity diagram. So for this project, the use case diagram is about to, first initially we need to activate the camera, and then by using neural network we are going to calculate the E aspect ratio of the particular person. So the E aspect ratio will vary from person to person. So it should be detected by using a neural network. For suppose some person's eyes are very big and some person's eyes are very small. Okay, and then a drowsiness detection, whether it is detected or not, we are going to use. Wait a second. I hope this is not visible. I turn off my camera. Okay, so activate the camera, acquire the camera images, and then apply the input images to the neural network classifier and detect the person is feeling drowsy or not, and at the same time yawn also. And then class diagram. So first the user should input conversation we need to give. So to give an input information, first we need to enable the camera, and then calculation. So to extract the features of the face we need to do the calculations, and then whether it is going to done with an E aspect ratio or not, we need to check. So under user, first it should recognize the eye, or it is a mouth, or it is a face. First it should detect the features. At the same time, after detecting the features, it should recognize the E aspect ratio. And then features of database using different kinds of neural networks, identifying the face. So this is about the activity diagram, the workflow, how it is going to be done. So first we are starting the camera and data collection. So by using real-time webcam, so this is a real-time project. So we are going to enable the web camera and collect the frame data. So first we need to convert the frame data into different kinds of arrays. So in the form of arrays we need to convert. So it doesn't know, our systems or our networks doesn't know this is a digital data, so analog data, it doesn't know. So we need to collect it and we need to make it in a certain manner which will be understood by the neural network in an easy way. So that is about the collection of or acquisition of data. And then after applying the neural network should compare the threshold value which is given by us in a code, and then E aspect ratio got by the input data. So then based on that it should give you the alert systems, and then it should stop the code. So here how to calculate the E aspect ratio, I just tell you. So initially I told you by using DLIB we are going to calculate the different kinds of landmarks on eye or a mouth. So first we need to calculate the mean distances. Wait, I just take the pen and I'll explain it. Okay. So here, for suppose this is an Ri. So Ri consisting of either X and as well as Y. So this is about to frame. On a frame, we are going to detect the I. So this, to detect on a frame, this is an I. We are using okay. So here I just detect this is the landmarks. Total 6 landmarks on a presented on a frame, which is shown here: P1, P2, P3, P4, P5, P6. Okay. So now I need to calculate the mean distance, or we call it as the E aspect ratio. So that the formula for calculating the E aspect ratio is the mean distance is P2 minus P6. The mod of, it should be in a mod of, then only it should be working, and then P3 minus P5 by 2. So then the distances between the horizontal ways. So these are the verticals. So P2 minus P6 distance, the I equal to distance, and then P3 minus P5 by the horizontal values P4 minus P1. So P1 minus P2, P4. Okay, so to calculate the I, in a same way for mouth also we are going to calculate the mean distances. We call it as the ratios and the distance of the mouth. Okay, so this is about the theoretical information regarding the entire project. So we are before going to moving into the project demo, I just announcing the quiz winners of the Day 5 Project Expo project demo on MIMO antennas. Mantri Shivakumar from Anurag University. Anjan Naik from the SDM College of Engineering and Technology. Vishwajit Mandal and National Institute of Technologies and Durgapur. B. Bindu Bhargavi from Spurti Engineering College and Harsha Venkat from DBOI College. Congratulations for all the quiz participants. So today also we have a quiz program. So we are going to share you the link in a description. You just go through that. So those who are win this quiz, you got the special certificates on this entire by IETE. Okay, so I'll show you the project demo now, the real-time implementation, how it is going to be working. Okay, so first I connect the see here, by using USB, I just gave the power supply. So the Raspberry Pi can able to capable of 5 voltage. So it is very low power consumption also. I hope it is visible. Okay. So now I connect this Raspberry Pi by using BNC to my laptop. So by using an IP address, I am going to connect with this. So here I am connecting web camera. Okay, so it will ask you password, user ID and password. The first step, I successfully connect my PC, my Raspberry Pi to the PC by using VNC viewer. So we should connect it to the same network. So here for my Raspberry Pi I have any even I connected web camera also, the same camera I am going to connect it here, so that's why it is showing. Okay, so now we will get into the project execution. So here this is my code, drowsiness. So first I will execute you, explain you code, and then after I will show you the execution. Just what are the necessary module and how it is looks like the architecture and all. Deepa, how the blinking of an eye is detected? Yeah, so by using E aspect ratio, we are going to find the threshold values by calculating the mean value, right? So I explained by using I mean values. So I got that value. If it is greater than the threshold value, so then less than the threshold value, so then we thought it is the eye is blinking. Okay, so the eye aspect ratio is different when we are closing our eye or when we are opening the eye. Voice is not audible. Is it clear now? The previous quiz already we are announced in a previous sessions, you just go through that. Is it audible? I hope it is clear now. Okay, so first I just go to the modules. So here I am going to working with a Raspberry Pi, so I just imported the Raspberry Pi GPU opens, and then okay, so SkyPy module. So SkyPy is for the classifier purpose we are importing, and then IMutils package. So IMutils is especially for the resizing the frame and the width and height of the frame. So now we are going to enable the camera. So then we need to decide the frame height and width, the video frame height and width. So for that purpose we are using IMutils and then DLIB. So D library function we call it as DLIB, D library. So first we need to import this DLIB functions. So all these are the packages, necessary packages. By using pip commands we are going to install all necessary packages. Only the one inbuilt package is about to Raspberry Pi, that is only for the Raspberry Pi users. So if you are running in the code in a Raspberry Pi device, so then this module is enabled, otherwise it won't. So this is an inbuilt module. And then CV2, so especially, so the entire is about to computer vision, so open source computer vision. So the module we need to import by using the same pip commands. and then subprocess. So why I am using subprocess here? To connect the SMS code here. So I just made it into the modules. This is about the one module, and here SMS code. So this is another module, and this is the main code. So I am going to run in between. So whenever I require an SMS alert, so then I run this code in middle. So for that purpose I just access this. And initially I am going to connect this buzzer to the 26th pin of the GPIO. So initially I set up the entire GPIO pins in a BCM mode, and then I just enable. So in a coding we need to mention that I am going to use this 26th pin as an output pin, okay, and then I calculate the E aspect ratio. So the defined E aspect ratio, so these are the inclusive values. So I inclusive value I1 and I5, so total entire 4 values are presented, 6 values. So from 1 to I, so this is a distance and then B distance, that is about to left eye and right eye values. And C is about to horizontal data. So finally I just calculate one ER ratio A plus B by. So I tell you in a theoretical way. So this is about to the coding part. So to find out the E aspect ratio, and then in a same way the lip detection values, the mean distance of the lip. So first thing we need to load we need to identify the landmarks. The landmarks of the lip is about to 50 to 53, 56 to 59 I just loaded. The shape of the lip I need to show it on a frame. So for that purpose I just get the features of the 50 and 50 to 53 top lip and then bottom lip. So both I just loaded the by identifying the landmarks I just loaded, and then I calculated the mean distances for both eye as well as the lip. So then after I just calculate by using argument phasor to phrase the arguments. So here we are using the DLIB predictor, the shape predictor I loaded into the code, and then I started the webcam. So here these are the threshold values. So initially the eye ratio is 0.3 or 5. It is somewhat bigger. So then whenever I close the eye, so then it will reduce to 0.25. Then that is a yawn detection, drowsiness detection. Otherwise it is not. So in a same way yawn threshold also it should be in a 20. And these are the frame rate. The frame rate should be it's depending upon your camera pixel rate. So if your camera is somewhat speeder, so good camera, so then we just use the high pixel frame rate like 48 likewise. So here I am going to use the web camera, not any inbuilt camera. So that's why I just decrease the frame rate to 10. So I load the detector called shape predictor. So this is about to, so here in a module I have this. So this is a hair cascade XML file which will detect the face, and this is the shape predictor which will identify the 68 facial landmarks on your face. Okay. So I just call this entire 68 shape predictor into the code. Okay, and then in the same way hair cascade files also, the two codes I just called it. So here I just call the shape predictor, and I started the video streaming, and then I am reading this. First every camera, every frame rate should be converting into the grayscale, because the color channel, the RGB color intensity, the channels are 3. It should very difficult to conversions purpose. So that's why converting into a grayscale image without extracting any features of my face. So here I am converting I am utilized for resizing the frame purpose. and then shape predictor I am calculating these entire values, E aspect ratio, left eye, right eye, these values. These are to help to draw a certain line on a frame, and this is about to rate. So whenever the counter, the threshold value is greater than that but less than the E aspect ratio, then drowsiness is alert. So whenever the drowsiness alert, it should send an SMS as well as buzzer alert, buzzer indicator also it should give. Okay. So to give an SMS, which SMS I need to send? So I store this drowsiness detected, drowsiness alert. We can tell it as a drowsiness detector or drowsiness alert. In the same way, yawn alert also. So first I will execute it. To execute this, we just need to go to the terminal with a directory. I already have the directory, I think so. Wait a second. Okay, I change the directory to the drowsiness folder, and then I am going to run this code. Even shape predictor also I need to load. Okay, both I am combinedly run by using this. It is loading. So first it will load the landmarks, and then okay. So by using if I am talking, it is ringing. So initially the E aspect ratio is about to 0.32, my E aspect ratio. Okay. So here if you see, I will show you the SMS I got. Wait. I hope it is visible. The yawn is detected. Okay. So here it is not loaded, so I just change the frame rate, then I can able to detect the drowsiness detector or not. So here only yawn is detected for me. So wait a second, I just change the threshold value. So my here it's night, so somewhat clarity is missing in my camera. Wait, I just try to change the threshold and then we'll find out the frame rate. First go to the directory. By using usage, you are going to another line missing. Yes, wait, I just change this now to 20. Okay. So even I got an SMS alerts also. So this is how we are going to implementing the session, this project in a academic outcomes, using academic outcomes. Okay, so somebody are asking some questions. I will tell you how to convert the color image to the, not only color image, the entire video into the grayscale conversions, right? So first initially I read this data. Okay, so gray is equal to, by using CV2 module, CV2 is generally for computer vision. So we have so many of features or functions are available. So in that we have a function called CVT color, convert color into the frame, and this frame is I read frames. Okay, in a frame variable I loaded the entire data which is presented on a which is camera input. I stored it in a frame variable. So the entire data I am going to apply CV2 dot color BGR to gray. So we share you the inquiry forms. Those if you want to need any codes or anything, we are not providing any source codes or anything. So if you need these projects or anything, you just fill the inquiry forms to contact us. We will reach you soon. Yes, we will share you the attendance link as well as quiz link soon, within 10 to 15 minutes. Okay, I just explain again Twilio cloud also, Twilio SMS also I didn't explain, right? So this is I just run this code in internally between the entire main code. Okay, so this SMS code is about to Twilio. So Twilio cloud provide, we need to create an account on Twilio, and they are going to provide you one Twilio number as well as API keys. So to connect those API keys as well as token, you just collect it from the cloud itself. Up to 6 months, this is a trial version. So then after you have to pay some amount. So in a log.txt, I save some data, send that as an SMS by using a file reading, file handling. I just read the log.txt file and then I send it as an SMS by using the function Twilio module. So we need to import the Twilio module also. Okay. So this is all about the project demo. we are going to provide the academic projects which is a customized project to the students. It is not like a project which consisting of including training. We are offering a mini projects, research projects also even for the PhD scholars. And we are in a training like we are going to offer certain internship and certified training programs in association with IETE, and then some short time training programs as well as workshops and different kinds of FDPs. And even we have in a channel, YouTube channel, up to 150 plus webinars we are conducted. You just watch it and you get definitely got enjoyed and you learn something by using those webinars and all. And we are going to provide a lab kits for the colleges and some hobby kits to the students, as well as IoT modules like Raspberry Pi devices or anything. We have in a products like brain sensor and then a gesture control board and speech recognition boards also. Any questions on entire session, so please feel free to ask. If you have any queries also, we are ready to rectify your issues or anything. So we are going to share the inquiry forms in a different, and if you are interested to do these kind of projects, we are ready to guide you. And not only the IEEE transactions also, every engineering student has an idea, so we are ready to bring it as a one outcome based, we are ready to make it as a model. So in a like real time applications by like using Jetson Nano or Raspberry Pi devices or Arduino, Node MCU or MSP 430 devices which is introduced by the Texas. So we are offering so much of different kinds of internships on a different domains, not only an IoT or in different domains. The domains we are offered is machine learning, deep learning, IoT with MLs and IoT with deep learning. So today I explained IoT with deep learning and MATLAB based project for electrical students. Okay, I hope all are enjoying this session. Thank you all. If you want to reach us on offline, we have branches on Chennai, Coimbatore, Tiruchi, Vijayawada, Hyderabad. Any queries, you just feel free to ask in a chat box. And if you are new to this channel, subscribe for more updates like this. Thank you all. Yes, thank you all. Thank you very much. What are the softwares we need to be installed? So we need to first set up the OS. So then in that we can install the necessary modules like iMutils, D library functions, and then the most important thing is computer vision package, CV2 module. So the addresses are displayed in a screen, you just go through that. I am displaying address on a screen. You just go through that according to your requirement. If you want to, yes, yeah, you will receive your certificates to your mail ID. You have to fill the feedback form and inquiry form. If you need any further queries on these projects or any queries related, yes. Yes, I'll we will update you in a description the attendance link and quiz link soon. You just please be patient. We will share you. Yes, the attendance link is in the chat box. You just go through that. Yes, thank you all. Thank you very much. So, for more wonderful updates, you can subscribe. If you are new to this, you just subscribe, and you are getting so much of technologies, latest current trending technologies. We are going to demonstrate you here, which is including academic outcomes. Yeah, that's all for today. Thank you.